Hi, welcome. I'm yet another Ham, and in this video I'd like to have a look at the TinySA Ultra signal generator together with you. So let's have a look and start. I've set the frequency to 15 megahertz, a level of minus 30 dBm, and now I switch the signal generator on, and let's have a look at the spectrum analyzer at the result. So what do we see? Let me switch the marker. Okay, so the reference level is measured at minus 29.4 dBm, so not quite half a dB difference, or a little more. And we have spurs there at roughly plus and minus 5 kilohertz, but no, not that bad. It is currently an unmodulated signal, so these spurs shouldn't be there, but with more than minus 50 dB below the carrier, that's okay. We can have a look at the harmonics. So let's see, for instance, at 30 megahertz. Okay. Minus 78 dBm, not that bad. So about minus 48 dB below the carrier. And what about 45? Another 10 dB less than the other harmonic. Quite nice given the price tag, what you have to pay for a TinySA. It's really nice. So let's compare it with the signal from my vintage Rot und Schwarz SMH. Going back to 15 megahertz and switching the SMH on. And what we can see here is that the noise level is about 8 dB less than the one from the TinySA, but that's okay. And no spurs as we saw on the TinySA. Unmodulated signal, but I'm not sure whether this is a fair comparison or not, because even if this is a vintage signal generator, if you look in the internet, you can find dealers which sell these for around €1,000. So I don't know what's the price tag on the SMH when it was new, but I'm sure it's more than you pay today for a TinySA. Let me reduce the resolution bandwidth to see whether the noise floor goes down some more. And apparently it does. So I will forward the video to the point where this sweep has completed with a selected resolution bandwidth of 10 Hertz. The noise drops down below minus 120 dBm, and let's see what picture we get when we connect the TinySA again to the spectrum analyzer with these settings. And this is what it looks like on the highest resolution bandwidth with the TinySA connected, and we see the spurs, the noise level, which is a little higher than the one from the SMH, but fair enough for the TinySA. The noise is about minus 112, something like that. Let's see. Yeah, somewhere around that, which is 10, 13 dB more than the one from the SMH. But again, given the price tag, quite a good result. So let's have a look how a modulated signal, for instance, amplitude modulation looks like. But I will increase the resolution bandwidth to get a more decent sweep speed. And to get some trade-off between speed and accuracy. An amplitude modulated signal. We go to modulation. There we choose AM and 1 kHz is okay. Let's start with 50% modulation depth and now we already see the result on the spectrum analyzer. And this is a little wider than that what I have expected. So let's see how the signal from the SMH with the same parameters look like. This is the AM signal from the SMH, and you can see that on the edges there are no spurs and no peaks from the modulated signal. Maybe we can have a look at this on the oscilloscope and compare the signals there. Here we see both signals. The upper one is from the SMH and the lower one is from the TinySA. And you see that the lower signal is distorted and you see the steps in the modulation, the discrete steps. It's a digital instrument, and to get a little better view on that, I will switch to a single channel and see what it looks like then. Here we have the single channel view, and you can see the discrete steps in the modulation. And this is why we see the spurs in the AM signal on the spectrum analyzer. And you can also see that the upper and the lower portion are not symmetrical. This might be due to the oscilloscope because it's only a 20 megahertz scope. So let's see, not that we blame the TinySA for something what he's not accountable for. I reduce the frequency to 1 megahertz, but honestly not really a big difference in that. But you might want to consider this depending on the application you're using the signal generator for. That's all for today. Hope you liked this video. If you did, leave me a like, and if you have suggestions for other videos, leave your idea in the comments. 73.